Hello guys, let us take up the solution to this problem. Uh, Says we have to find the angle which a pair of compasses should be opened so that the pivot is as elevated as possible when we suspend the compass from one of the ends by using a string, as it has been shown in the figure. Before doing this problem, let us first model it. Model the compass by two identical rods, each of length, say for example, twice L. So first of all, in order to find the required angle, we first prove a claim. Claim in this case that in this situation, when the pivot is as high as possible, the lower arm must be horizontal. Meaning that we should have in this case the following situation: if we want the pivot to be as high as possible, which will explain why that is so, by the way. As I said, in this case, if we supposed to be of identical lengths suspended by means of a thread at the end, you should notice that the center of mass of this pair of compass will be the midpoint of the line joining the midpoints of the two arms. That is because they are identical actually. So we can replace each of them by point mass at the corresponding center, and therefore the center of mass of this full thing, first of all the midpoint of these two, and then the line which joins the midpoint, that will be the corresponding center of mass. So the diagram is not very accurate in this case, so we are going to end up at some different location. Let's try to make it such that we know that at least as far the equilibrium is concerned, in that case the center of mass must be on the line which is on the suspension itself. So I would like the center of mass to be lying on this line actually. The angle has to be actually a bit less or more. Let's modify diagram a bit. Let's prove that the suspension, or rather the pivot, is as high as possible only when the lower arm is horizontal. Starting from this position, if we suppose that the upper arm is fixed, held at position, and the lower arm is either opened or closed a bit. Say, for example, we open or close a bit, like in this case, it has been closed, in which case, we'll find that the center of mass moves to the right a bit. Why? Because the center of mass of the lower arm is going to be a bit rightwards. And that is why the overall center of mass will also move rightwards. And that is why if we release the upper arm, the pivot must go down. It should turn so that the center of mass goes down over here, which implies the pivot has to go down, isn't it? And that proves, therefore, that initially when it was horizontal, the pivot was the highest point. It can't go any further up, because even if I open the arm, even if I open the lower arm a bit instead of closing, if I just open it out, even then I find that the center of mass of the lower arm moves towards right a bit, and therefore overall center mass also moves towards right. And therefore, once again, if I release the upper arm, the pivot is going to go down. So in any case, if I deviate the situation from this position when the lower arm is horizontal, in either case, either closing the compass a bit or opening it up, in both cases, the center of mass, the pivot actually, it goes down. That is why the pivot must be the highest position when the lower arm is horizontal. Okay, with that settled, let us take up the problem of finding the angle. That is going to be now a bit of just a bit of geometry, because We already know in this case that uh, lower arm is horizontal. So if I extend the suspension line, which is this one, till over here, we know in this case that I have taken a total length to be twice L. So if this one is L, that is L. This part, let's name it O, A, B. Midpoint segments are M and N. This point is D, which is perpendicular. And this point where the two lines intersect, let us make it solid. So wherever two arms intersect in that case, that point we are going to call as, for example, oh, as I said earlier, diagram is not exactly perfect, but we know in this case, let's call P. We know in this case that this actually is a midpoint. These two are supposed to be equal. And therefore, if I consider joining this vertex O to the point P as well, we know because if we consider the angles, in this case, if we consider as the full angle to be twice theta, for example, we um, can see that that is, I mean, triangle MON actually is in fact isosceles, because OM and ON both are equal to L. Therefore, OP, which is actually bisecting MN rather, must be not only perpendicular to MN, but also the angle bisector of angle MY. So what we need to have is angle MOP and angle NOP are equal. So I can take both of them as angle theta. As I said, diagram is not accurate, so we won't see that. This is 90 degrees as well. So we can kind of consider this MP lengthwise, that becomes L sine theta. Now, because that is 90 degrees, this angle is twice theta, therefore this is 90 degrees minus theta. So we could in effect apply the sine rule in triangle PMA. That should give us required result. We require the angle theta, remember. We already know MP in this case is L sine theta. And MAN is also L. The lengths are known, so I require this angle, which is already there, and I require this angle as well. What about this angle? What can we conclude about that angle in this case? In that case, we consider this angle is 90 minus theta as well. Sorry, the upper part is 90 minus 2 theta actually. Okay. That is 90 minus theta. So I know this angle as well. That angle over here is going to be 90 minus theta minus 90 plus 2 theta. So it implies this is theta itself. That angle is actually turning out to be why it is there, that is also known. um, because that's an external angle, angle OMP. So that will be the sum of these two angles, angle MAP and angle PM. Therefore, this angle is turning out to be 90 minus theta minus 90 minus 2. That is same thing as angle theta. Therefore, I know that angle as well. So in that triangle, if I consider both the angles known to us, so apply the sine rule. In triangle PA, what we have, that will give us in this case angle M, we consider L by implies L is this length AM divided by sine of this angle, that is theta itself. So AM by sine theta will be same thing as PM. PM in this case is L sine theta by sine of the opposite angle, which is 90 degrees minus 2 theta. L gets cancelled out. We bring sine 90 minus 2 theta, which is cos 2 theta, to the left side. We're getting cos 2 theta is equal to sine square theta. It is simple matter to solve because cos 2 theta is simply, you can consider it to be 1 minus 2 sine square theta. That must be sine square theta. And that gives us the required angle. It gives us sine square theta equal to 1 by 3, giving us sine theta as 1 by root 3. And therefore, the required angle theta is sine inverse 1 by root 3. And accordingly, the final answer, which is 2 theta, is therefore written down as twice sine inverse of 1 by 3. That becomes therefore our final answer, which I could write down separately. Required angle is therefore 2 into sine inverse of 1 upon root 3. We can compute approximately how much this value is. Um, Around 70.5 degrees. That will be the final answer. Okay. Thank you for watching this, and we'll have more questions and answers coming up. So check out this space. Thank you.